everyone. Today I'm into my topic. CNN for remaining different life relation and XAI approach using SHAP for model in presentation. The presentation content include 4 parts. First content is second part, robust approach for revision, experimental result and revision and conclusion. You see in the picture, in smart factory setting, maintaining in stability and in uninterrupted operation machine and equipment fundamental goal of the production project. Important for previous maintenance in smart factory, minimize downtime, previous maintenance and will compare to previous when equipment is likely to fail and perform maintenance just in time to prevent breakdown. This minimize unplanned downtime. Increasing equipment supply by maintaining machine by on actual conditions the time by schedule. Manufacturing can avoid unnecessary plug and repair. Extend operational lifespan of equipment and reduce capital expenses. Increase reduce maintenance cost, reduce maintenance use data from sensor and monitor equipment health in real time, allow to by scheduling maintenance in reduce fault in frequency of increasing investing and also on cost and repair. Expose is the set you see in spec risk in manufacturing environment by previous fair before they account previous maintenance have maintain safe working condition, reduce accident cause and malfunctioning equipment. Optimize result OC with previous management team can optimize issue the OPA, labor and other result by plan here. And the change transition method model by upfront. Your partial model and multiple expression. Change complexity in the model require expect knowledge of system pricing. Stability is difficult to apply across various systems or when operate condition change. Lack of flexibility should reach online or noisy data. If you use statistical approach, rely on static technique, line regression or reliability model. Limits from Whistler data and absorption of data distribution and inflexibility. With model with the deep learning approach, you models like CNN or LSTM to automate pattern from raw data sensor. Advanced hand complex data learn non-linear relationship and interaction between variables. Flexibility can be applied across different systems without knowledge of system passive. Training and of machine learning model interoperability hard to explain why most models make space with a correct and usable data dependent with large amount data of training, which can be difficult to obtain. Computationally intensive training deep learning model require significant computational result. Use of a deep convolution neural network to predict remaining input line. Convolutional layer extract spare feature from sensor reading. Polling layer review the dimensionality of the data while present key information specific of computation. Fully connection layer compile the linear feature to predict the root value at each time step. Advanced of using DCNN for rule. Robots to know DCNN are recently to know data which is common on real world sensor reading. Suitable different operating conditions capable of learning generate feature that apply to multi-operating model and fail time. Time expected in prediction on the chain DCNN can make real-time prediction which is scheduled for industrial application on predictive maintenance. Training the DCNN input time series sensor data loss function using loss handle outlet in the rule prediction. Optimization optimize to research assert way of the network during training. DCNN output predict rule of each time step. Row diving continue modeling of machine health and informing across maintenance decision. You see in the picture, you see it plan mobility in rule revision, black spot nature of DCNN, wide convolution neural network provide high accurate remaining useful line revision. They is decision making process is often not transparent. It's a lack for interoperability can lead to trust issue the industrial application, where understanding why a model makes a certain prediction is critical or reliability. XAI refers to a set of methods and techniques that make the output of a machine learning model understandable to human. It AI help to provide insight into how model like DCNN arrive at their prediction, which is crucial for gaining truth from engine and decision maker. Feature condition SHAP calculate the condition of X sensor to the previous rule. Positive value indicate that the feature increase the rule prediction, while negative value reduce it. Model transparent is by implant which sensor and the most influential in previous rule SHAP make up the DCNN prediction more interpretable and truth tolerant. The CMAT dataset we developed by NASA to simulate the degradation of the two-part engine. It was you predict the remaining useful life of engine and in the context of release maintenance. And you see in the slide have 21 sensors and 4 subnet. You see in the table, each subnet contains learn to fail data of multi-engine, allowing machine learning model to learn from history fail after. Time series data sensor reading are provided for each time check until the point of fails, making in the entire dataset of the trained model to predict rule. Processing step. Each data set in CMAT set has in ID cycle 3 operating mode and parameters from 21 sensors. We remove some sensor measurement to process the data before begin training on the model because they provide specific information which contain output, thou, modular. Yeah. And normalize, we normalize ensure that on sensor data on the same scale. We run DCNN model for 4 data set. And those means where error prediction result are stored in the table. And result in divide with different ID for engine as shown in the picture with the different between predict and actual value predicting rule. And you actual rule value in order line the values given before motor degrade of 125 and remain the same for the long time, then agree on 0 to 0 to indicate the time when the motor reset and in last cycle. And you see in the picture in result, I use XAI result, so in the picture PDA, okay? This is plan it for the final release value, the model after on the feature have been considered. Sensor line, sensor tail, sensor X, sensor 20 increase of release value. Sensor 21 and sensor 9 decrease the release value increase over the max. Final release remain the same in the paid value. The conclusion. We use the DCNN model combined with the model explainable technique and predict the rule and the two-organ engine yield data. Our model can actually predict rule while provide detailed information about the sensor and pattern that smart issue and engine project. Using SHAP to explain the model predict allow you then the heuristical sensor that effect and in and point out response of the engine effect is implied. Thank you for your time and attention.
Thank you very much. Any questions from the floor?
Thank you for the presentation. I have one question because I didn't understand which kind of information your sensor give. Because for classical math engineers, they use data like failure rate of components, or mean time before failure, or mean time before repair, and so on. So, do your sensors are capable to assess such indicators that are usually understandable by an advanced engineer? Because in fact the output, I didn't understand also the output, because you say in your introductions that it is a support for helping agent for predictive maintenance, okay, and for remaining useful life prediction. So I didn't understand if the output of the system answer to the goal of your introduction.
Dataset, CMAT dataset have 21 sensor. When I research, I see some sensor the same signal. If I use sensor chain model, maybe it's a long time and the same.
I think the question from the audience is what kind of sensor, what kind of output of the sensor, and what is it for?
Yes, output.
You got in total 21 sensors, but what kind of sensor? What is the output of the sensor? That is the output for?
Output for.
Yeah.
Output for.
No.
If I have a lot of sensor, we don't understand what kind of sensor you are using. Like sensors.
When I use sensor dataset, I don't know, but you see some sensor temperature, appliance, or I don't know. But
the question is simple, contrary. My question is regarding your model. Of course, your artificial intelligence-based model has input, okay, coming from sensor, and of course your model has output. So regarding the goal of your studies, you said that you want to improve predictive maintenance. So my question is, how can you improve predictive maintenance with your model regarding the output you propose with them? Is it clear?
Yeah, I clear.
Okay.
Output is the regression. When I use a K model in here, output regression, I use K model, use each plane IO and each plane for output.
Thank you.
Hello, excuse me. If I may actually I'm also the second author of the paper, so maybe I can answer your question more clearly, if I may. Thank you, Hoang, for the presentation. So, regarding your question, actually this data set is a simulated data set from NASA for the engine turbine, and the sensor actually has 21 sensor or more measurement of the. We have actually there's a list on the sensor, but we do not have. It's something like, for example, the pressure or the temperature or the thickness of the sea line, etc. So the output, these are the simulated data sets. So they simulate the output based on the condition that they simulate the condition, and based on the simulation they consider that okay, under this condition the output is not good to operate anymore. So it's called failure. So everything the artificial, it is not the real data, but actually it's a simulated data from the simulation. So the output, that's why we know what is the failure under which condition. For example, the border or the wall on the engine, or the thickness of the material, the grain or something like that. That's considered the failure in general. Is that exactly your question? Hello?
Thank you.